Today's sequences and partial sums. So arithmetic sequences are sequences that are jumping by a specific number, like example would be like adding 5 to each term. So like 3, 8, 13, etc. would be like that, or maybe subtracting. So if we had maybe 27, 20, 13 as a -7 pattern, right? Both of those would be arithmetic sequences, right? So again, that number that we are jumping by is called D, standing for the common difference, okay? And if you couldn't mathematically see 3 to 8 plus 5, the formula is to go backwards. 8 minus 3 would give you 5. 13 minus 8 should also give you 5. So it's a way to check if it's an arithmetic sequence or not. So starting off, we got 16, 13, 10, 7. Determine whether it's arithmetic or not, right? So 16 to 13 to minus 3, 13 to 10 to minus 3, 10 to 7 to minus 3. And so minus 3 is our common difference, and yes, it is arithmetic. Next up, we've got 1/2, 3/2, 2, 5/2, 3, 7/2. Now this one is also arithmetic, but it might be harder to see. So if you struggle seeing it, write the numbers that don't have a denominator with a denominator, right? And basically multiply by 2/2 to turn those into halves, and I get 2/2. Next one's 3/2. 2 times 2 is 4/2. Next term 5/2. 3 times 2 is 6/2. Then we got 7/2. So clearly we're adding by 1/2. So this one's a yes. B is 1/2. Last one, we've got 2, 6, 18, right? And if we see, we got to jump with +4, but the next one's +12, right? That is not the same, so that is not arithmetic. Next, the nth term for explicit formula of an arithmetic sequence, we used to use this form, but here's how I'm going to use it. A sub n equals D, what we're jumping by, times n. And I like to call this term plus a sub 0, the term before the first term. So I'll show you in some examples in a little bit, but basically we're going to do one jump backwards from the first term, which is technically what this is saying there anyway, but it's just a little easier than using that large of a formula. So, starting off, find the explicit formula of the arithmetic sequence, and then find a given term. So we've got 3, 1, -1, -3, -5. And looking at this, I see a -2 pattern, right? We're getting smaller and smaller. So D is -2. Now, we've got A sub n is -2n plus, and we're looking for what is the 0 term. So the 0 term, I'm going to go the other direction, right? If I'm going the other direction, it's +2, right? Going from 1 to 3, +2. 3 plus 2 gives me 5, and 5 is that 0 term. The term before the first term is 5, so when I plug that in over here, I get -2n plus 5. Now, if you're not confident in your answer, a quick check is just to plug it in. -2 times 1 plus 5, 5 minus 2 is 3, which is my first term. Usually I like to do a couple terms just to make sure I didn't find something that worked just for one. So -4 plus 5, 1, worked again. And the last one, -2 times 3 for the third term. 5 minus 6, -1, and so we match. So this is our equation. And now we're going to plug in 21. The 21st term is just plugged in 21 for the n value. And so I get -42 plus 5 gives me -37. And so -37 is my 21st term. Next one, another weird denominator one. 15/4, 9/2, 21/4, 6, 27/4. Right? So I'm going to write these all as 4. So this one needs a 2, this one needs a 4. So I'm going to rewrite this 15/4, 18/4, 21/4. Now it looks nicer. 24/4. 27/4. Now, the bottom stays the same,
but that just means that we're adding a number of fourth. The top is plus 3, so this is another way to write plus 3/4. Right, so I have 3/4 n, and then what's my sub-zero term? I'm going to subtract, right, we're going right to left now, minus 3/4 minus 3/4. So I'm basically doing this math, which gives me 12/4, which is 3. So 3/4 n plus 3. Now, I sometimes like to leave it in this form when we're getting into this a sub 13 term. Okay. I'm not going to double check every answer, but if you lack confidence maybe in one of your answers, it doesn't hurt to plug it in and check. Okay. So now the 13th term, right? And this is where the fourth might help, because we're going to plug in 12/4 here, because it will help us add anyway. Again, that's where the 12/4 came from. So 39 plus 12 gives us 51/4, and that's going to be our answer. And simplify if you can. If you can't, just leave it. Continuing on. First term is 15. The next term is the first term, or last term, plus 9. Right? So sometimes I like to write out a couple terms. So if I plug in 15 here, the second term is 15 plus 9. The third term is, right, 24 plus 9. And the fourth term, probably set already, 33 plus 9 is 42. So I have this sequence of 15, 24, 33, 42. And the pattern is plus 9, which is conveniently right there. So 9n, and now I got to go backwards one term. So minus 9, right? Because if you need to do it twice just to see the pattern, it's fine. 15 minus 9 gives us 6, is that a sub 0 term. So 9n plus 6 is my explicit formula. Plugging in 12. 108 plus 6 is 114. And again, you can do that on your calculator as well. This doesn't have to be by hand. And that gets us our answer. Moving on, we've got the second term is -2, and the fourth term is 12. Okay, a sub n equals. Now, when we do it this way, I usually like to kind of label my blanks. Sorry, didn't come out right. Just so then you can kind of see, this is arithmetic, right? And we're trying to see what's the jump, right? Because we got plus a jump, plus another jump gives us 12. So the distance from 12 to -2 is 2 jumps. Well, where does that 2 come from? It comes from technically 4 minus 2. This is kind of like slope formula, where 4 and 2 are x's, per se, and these numbers, -2 and 12, are our y values. Right? So we're doing 12 minus -2 to get us, sorry, I forgot my parentheses there. 12 minus a -2 gives us 14 movement in jumps. And 4 minus 2 gives us the number of jumps. 14 divided by 2 is 7. So this one is jumping by 7. And now we need to go back and find out what's that first term. So there's 2 ways to do this. With this situation, I would just subtract twice. Right? Because now that we know it's plus 7, going this way, minus 7, this would be 5. 5 minus 7, -2. -2 minus 7, -9 is the first term. -9 minus 7, -16 is that sub-zero term. A sub 0. So you get 7n minus 16. That's one way. Another way is, right, we can use the a sub n equals dn plus a sub 0 formula. Okay? So what you're going to do is plug in what you know and then solve for a sub 0. So a sub 2 is -2 equals 7 times n is 2 plus that first term. Right? This is kind of like a y equals mx plus b way. This is 14, so we need to solve. So I'm going to subtract 14 from each side and get that -16 is that a sub 0 term. Now this is generally the recommended method if you're dealing with terms kind of much larger than 2.
So, meaning if I started with like the 5th and the 9th term, it might be a lot of work to subtract my common difference 4, 5, 6 times to get there, okay? So that's explaining where this came from for those who are like, wait, how is that a final answer? That's just part of our sequence explicit formula. And now I need to plug in 15. So plugging in 15, 7 times 15 minus 16, I get 99 off the top of my head. Double checking, and 99 is not correct. I got 89. So 89. Double check. Yeah, 90 plus 15 is 105 minus 16. Okay. 89. Moving on to the next portion. There's a pattern when you add a finite arithmetic sequence. I don't know who discovered it. I've heard plenty of stories about some mathematician whose teacher was challenging him and told him to add the first 100 numbers together to find the sum. And he did it in like 2.5 minutes and came back with an answer that will basically follow this pattern. Right? So the pattern is n is the number of terms you have divided by 2 times the first term plus the last term of your given sequence. So be aware, or beware, not all summations, right? Not all summations will start at 1, right? You might have one that starts at 7 and goes to 27, right? So in that case, the 7th term would be our first one. Sounds backwards, but from that situation, we start at the 7th term of the sequence. We're not starting at sum 1, okay? But the pattern still works. Okay? And reminder, the partial sum is the first, like if we had a third partial sum, that'd be the sum of the first 3 terms. So we've got 4, 16, 28, 40, and it wants to find us to find the sum of the first 12 terms. Right now in summation notation, this looks like we got 12. We've got the first term using our pattern. I can see a plus 12 going on. So my minus 12 gives me 12n minus 8 is my pattern. But more importantly, right, I actually just need to find, right, the pieces that are in this formula. Okay? Right? So I have n is 12. I have the first term here is 4. However, I needed this formula to find this a sub n term, which in this case was my 12th term. Okay? So now that I have 12n minus 8 from kind of a quick math of the previous one, we were jumping by 12. 4 minus 12 gave me 8. So I've got 12 times 12 minus 8. 144 minus 8 is 136. And so plugging them together, we've got 12 groups divided by 2 gives us 6 pairs of the first number 4 plus the last number 136. So 6 times 140, 600 plus 240 gives us 840 is the sum of the first 12 terms. Okay. Moving on. Next up is we're finding the sum of the terms 3 through 42 of this. So again, I need n, but this time I can't just grab this number, okay, because we have terms 3 to 42. This is the same idea as if I assigned you problems 3 to 42. How many problems did I assign? So it's really 42 minus 3, so top number minus bottom. However, it's not really accurate, right, because I'm taking away number 3, and number 3 is in the mix, so I have to add 1 back in there. So subtracting 3 gives me 39 plus 1 is 40. And again, the real idea is we're 42 and we're subtracting 2 because we didn't do number 1 or 2, right? That's why that math works out. So n is 40, and again, we're filling in what we have. So I need the third term and I need the 42nd term. They gave me the formula, so I just need to plug it in. A sub 3 is negative 5 times 3. Negative 15 plus 3 is negative 12. Case of 42 might require some calculator work. So we got negative 210 plus 3 is negative 207. And so plugging in what I had, 40 over 2 of negative 12 plus a negative 207 gives me 20 times negative 219. gives me 4380 with a negative in front. 4,380 of the negative variety. Calculated work. Moving on to the next one. 1 to 100 of this. Now in this situation, because we start at 1, I can just take n equals 100. Okay, because I don't need to do 100 minus 1 plus 1. This just gets me 100. Okay, so in this rare occasion where you start at 1, n is 100, first term is 7 times 1 minus 50. 7 minus 50 is negative 43. 100th term, 7 times 100 minus 50. 700 minus 50 is 650. And so now I have 100 divided by 2 times negative 43 quantity plus 650. It gives me 607 times 50. Something like 30,350. Calculator work, again, you just want to plug that in. So there's your final answer. And then one more. And this one's in a little uglier form. The third term is negative 2. The 11th term is minus 42, and we want the first 15 terms. Right, so we need to find the formula. So this is the one where we need to use slope, right? We're doing 11 minus 3 on the bottom tells us how many jumps there are. And the distance we covered, negative 42 minus a negative 2, gives us the common difference. So negative 42 double negative plus 2 gives us negative 40 over 8. So we're subtracting by 5. Okay. So now if a sub 3 is negative 2, this is negative 5 times 3 jumps plus the first term. So this is minus 15. I need to add 15 to both sides and get 13 is my sub-zero term. So I have, n is 15 right away. Now I have a sub n is negative 5n plus 13. And now I need to find the first term. A sub 1 is negative 5 times 1 plus 13, which is 8. And I need to find the 15th term. So negative 5 times 15, negative 75 plus 13, sounds like negative 62. So when I plug them together, 15½ times 8 plus minus 62 gives us a total of minus 405. That wraps up today's lesson. If you have any questions, feel free to shoot me a comment.